Hello, my name is Chase Knutson, and we're going to be going over lab number 1, constant velocity. In this presentation, we're going to go through the introduction, fundamental physics principles, which is Newton's laws, procedures, tracker analysis, potential errors, and what-if questions. What was the lab? Lab 1 required recording a video of an object moving in either the positive X or Y direction. In my case, I filmed an expo marker sliding along a surface. The goal was to create motion that closely resembled constant velocity. After recording the video, I used Tracker to analyze the motion to determine the position of the marker over time. And then I used that tracker to create a glow script to predict the marker's position based on physics principles. The purpose of the lab. The main purpose of the lab was to determine whether a computational model could accurately predict the real motion of the marker. Specifically, we compared the actual position data measured in Tracker versus the predicted position generated by our code model. This lab demonstrates how physics principles can be used to model real-world motion, while also showing that small differences may appear between calculation, predictions, and observations data due to the real-world imperfections. Fundamental physics principles used in Lab 1. We started off with Newton's first law. An object at rest stays at rest, and an object in motion continues at constant velocity unless acted on by an external force. Newton's second law. The net force of an object determines its acceleration. If the net force is zero, the acceleration is zero. Velocity concept. If the velocity force is zero, the object's velocity does not change. Velocity. If the net force is zero, the object's velocity does not change. And we derived F net equals dp over dt into the velocity update formula. Procedure for lab 1. We had to record motion. And then we had to track the position. Then we had to build computational models. Then we had to compare and graph. Tracker output. Set scale. Using known distance in the video to calibrate tracker. Align axes. Position the X and Y axis at the starting point. Track motion. Move the center of mass of the pencil frame by frame. Interpret data. Use the track position to analyze motion and determine velocity. As you can see, the average velocity for my model was 0.53 meters per second. Here's the code that I wrote. And here's the difference between the tracker and the glow script. It's pretty accurate. The glow script is in the orange and the tracker is in the blue. Potential errors. External forces, like friction between the pencil and table, or air resistance could affect motion. Tracker accuracy. Manually tracking the pencil's center of mass frame by frame may introduce small errors. Rounding errors. Limited decimal precision can slightly alter recorded positions. What if? Forces acting on the pencil. Is it possible to say how many forces are being added together to give zero net force in the case that you observed? No, it is not possible. Other forces such as friction and air resistance affected the pencil. Difference between the computational model and the actual motion show multiple forces contribute, but we cannot determine how many individually. Thank you.